Welcome back, everyone. Welcome to the second video in this factoring polynomials unit. The topic for this video will be grouping, or the grouping method. Let's get right into it. The grouping method is used for 4 or 6 term polynomials. So you can see these have 4 polynomials. 4 terms. So you know when to use grouping because it looks quite distinct. How to do it? Break the polynomial into 2 equal groups. Now, I have a red imaginary line. We don't want to put brackets in or anything like that because that's going to change the meaning of the polynomial. So I'm just going to use this imaginary line. Next, we're going to use our greatest common factor skills. I want to pull out a greatest common factor from the left side or the left half. All right, well, the greatest common factor that I can see, it jumps out pretty good. It's just x. So x. Then I'll go through and write my adjusted polynomial once I've removed the x. So xy divided by x is just y. And then 3x divided by x is just 3. Once you've done that, erase everything from your mind and start over again. Take the GCF from the right half. All right, looks like 2 to me. Now we need a sign. So always pull out a positive unless you see 2 negative signs. So what I mean by that, if these were 2 negatives, I would pull out a negative. Otherwise, pull out 2 positives. Now, sometimes there's other cases where we need to pull out a negative. I will show you in this video later on how to adjust things with that negative. All right, but back to this. I'm pulling out a GCF. I'm going to say it's 2, positive 2. Oh, sorry, it's green there, positive 2. Ah, still green. We'll keep rolling with it. Divide the 2 out. I get y plus 3. Hopefully you notice that we have matching binomials now. Once this occurs, you know you're on the right track. If it doesn't occur, it means you have to pull out maybe more for a greatest common factor, or you might have to rearrange your polynomial. We'll look at a rearranging question later in the video. But for this one, everything looks good. So my next step is actually pull out that common binomial, y plus 3. Once I remove that common binomial, again, that's its greatest common factor. When I remove it, remember, you're really dividing it out, and you write your adjusted polynomial down. So then I just have to really gather my leftovers, which is x plus 2. So that will be the second bracket, x plus 2. Now, that might seem strange to you. I don't want you guys just to believe me. Let's actually multiply it out and show that it works. So y plus 3, x plus 2. Okay, xy. Always write things in alphabetical order. Helps things stand out. Plus 2y, plus 3x, plus 6. Now you might notice that the 3x and the 2y are in different positions, but that's okay. In addition, we can mess around with the arrangement. It still means the same thing. So we have the correct terms. They're in a slightly shuffled order, but that is okay. So hopefully that proves to you that this method works. All right, let's do it again. So first thing, make my imaginary line to divide this thing in half. Then I'm going to look for the GCF out of the left half, and then the GCF out of the right half. Make that blue. All right, so the GCF on the left half, that's going to be 2m. Want to divide 2m out, I get k plus v. If that doesn't make sense, how to pull that GCF out, make sure you watch the first video in this series, the greatest common factor. If that still doesn't make sense, find a teacher or come find me. All right, the right half. Okay, you can see that we have 2 negatives, so I'm going to pull out a negative. We need to have a sign in this position. So we need to have something here, something here. All right, so negative, and then there's y's in both of them. So negative y. Man, I can't, this black does not want to work. Negative y. Once I do my divisions, negative ky divided by negative y is positive k. 2 negatives make a positive again, so plus v. And once more, you see that we have matching binomials. Once we have matching binomials, we pull that out, k plus v. So really, we apply the greatest common factor 3 times. Once in the left half, once in the right half, and then once when it's in this partially factored form. Once we pull it out, what we're really doing is dividing it out. Pull together the leftover terms, 2m minus y. A little bit more. So imaginary line. Greatest common factor, 3s. Once I divide the 3s out, I get 2s minus 5m. Start over again. I see that I have a positive and a negative, and like I said before, unless they're both negatives, for right now, always pull out a positive. So positive. 20 and 8. 4 would be a greatest common factor, and then you can see that there's k's in each term, so plus 4k. Divide that out, I get 5m, and then I get negative 2s. Now, if you check your brackets here, they are not equal. They're actually opposite. I have negative 5, then positive 5. I have positive 2s, then negative 2s. How do we adjust that? Well, that is the exception to my little rule. That is where we go back then and make that a negative. Because now positive 20 divided by negative 4 makes negative 5m. Negative 8 divided by negative 4 makes positive 2s. Now they match. So I don't worry about the signs. I only pull out a negative when both are negative. And if I need to pull out a negative, if I missed pulling out that negative, it'll show me like this. Okay, keep moving. I pull out now this greatest common factor, which is the binomial, 2s minus 5m. Doesn't matter if I would have chosen to write it as negative 5m plus 2s, whatever you wish. And then pull together the leftovers, 3s minus 4k. 6 terms. Nothing changes. Now I just have to, again, divide it in half. It's just I have my sets are sets of 3 rather than sets of 2. Okay, and I'll think about this. 6, 3, and 12. So 3 is common, and I see there's an x common to everything as well. Start dividing everything out. That's going to be 2x. 3xy divided by 3x will be positive y. Negative 12x divided by 3x, a negative divided by a positive is negative, and then just 4. All right, so I know what I want my next bracket to look like. Let's see if it works. Again, I only have 2 negative signs out of 3, so we'll stick to that rule for now. Once you do more of these, you'll know when you can pull out a negative and when not to. So I'm going to say positive for right now. And then 4, 2, and 8, so 2 is a GCF. And there are no common letters, so I only see 1x, 1y, and then 8 doesn't have any variables, so just 2. So now I'd get negative 2x. And right away there, I notice, well, negative 2x on this one, but it's positive 2x over here. So really, that's kind of my indication. This should have been negative, so now that's positive. Negative 2y divided by negative 2 will be positive y. Positive 8 divided by negative 2 will be negative 4. And now we can see these do indeed match up. Okay, pull out my GCF, which is this common trinomial, 2x plus y minus 4. I've divided that out, so now just gather my leftover terms, 3x minus 2. Feel free to multiply that together to double check it works. But spoiler, it works. Okay, another example of a 6-term polynomial. So once again, my method does not change. I have my imaginary line. Look for my greatest common factor. If you don't know how to, or don't understand what a greatest common factor is, again, you've got to get that down before you move on. I check out my numbers 8, 8, 4, so I know 4 can be used to make all those numbers. And I see that there's an x common to everything, so 4x is my GCF. Now I'll go through and divide. I hope I'm not going too fast. That's 2x. Negative 8xy divided by positive 4x is going to be negative 2y. And then positive 4x divided by positive 4x is plus 1. Now, you might wonder, I thought you said you don't have to write the 1's down. You have to write a 1 if it's the only thing there. So I can't just write a plus and then nothing, so plus 1. All right, other side. Again, make sure you pull a sign out. Okay, so if I look at the numbers 4, 4, and 2, I know 2 is going to be my number. Sign-wise, I know I want to, if I look over here, I want that to be positive. So I'd have to pull out a negative here to make that first term positive. So that is my tip. Pull out a negative, and we already said 2. And then if I check, there's a z in everything, so negative 2z is my GCF. Now go through and multiply. Negative divided by negative is positive. 4 divided by 2 is 2. The z's will cancel, so I just have x. Positive divided by negative is a negative. And then 4 divided by 2 is 2. And then again, the z is gone. And negative 2z divided by negative 2z, two negatives make a positive. Double check. My brackets match. So I can just finish this question off, pull out my common trinomial, and then write down my leftovers. Now, not every grouping question can be done right away. Sometimes you have to regroup. I really suggest don't try to regroup until you've failed at the question. So your brackets don't match, you've proven, oh, this arrangement isn't correct, then start to rearrange. If you attack every question like looking to rearrange, your assignments will take forever. And it doesn't have, not many textbooks have a lot of rearranging questions. Mostly they're ready to go. So let's assume they're all ready to go. And if it doesn't work, we have to rearrange. So I'll show you how I would kind of clue into that. Here's my GCF. Okay, on my left half here, I'd have, well, there's nothing common there. Well, there's right there, okay? Now, if there's nothing common, I can pull out a positive 1, and then nothing would change here. But for our algorithm, for this patterned way of getting an answer, I have to pull something out. Now, remember, my next bracket has to match that first bracket. If I look in this next one, there's nothing common in this one either, so all I can pull out would be a positive 1, and then I look, and we're not matching. So if the brackets don't match, you know that you are wrong. Okay, so I have to rearrange my terms. Okay, so I'll just draw this line so I can redo this. Now, look for things that have common factors like 14 and 35. I know those have common factors, so I'm going to go 14 MP. Now, how do I make that decision? Well, 14 and 35 have 7 in common, and they both have M's. So 14 MP plus 35M. Make sure you don't change the sign by accident. So I've dealt with this guy and this guy. That means then the other two have to go together. Negative 5N minus 2NP. Don't worry about things like what goes first. Just write however you want to write it down where you think things are common. So meaning if you wrote the 35M first, then the 14MP, you would be fine in the end. Don't worry. So we'll start over again. 14MP and 7M. I already said, well, sorry, and 35M. I already said that 7M is common. So I'd be left with 2P plus 5. On this other right half, I see a negative and then an N. So I'd be left with positive 5 plus 2P. And you can see the brackets are in a different order, but these brackets are equal. Positive 2P, positive 2P, positive 5, positive 5. So all is good. We rearranged and saved the question. Pull out what's common, 2P plus 5. And then the leftovers, 7M minus N. If you would have wrote the 5 plus 2P first, that would be fine as well. It would still work out. It still counts as an answer. Final example. Let's get into it. 6 and 10, I see, well, that would be common. And a C, so I would get then 3M minus 5J. Okay, that's what I got to make the second bracket look like. I see that they're a negative and a positive, so they don't match up the sign, so I'm just going to say positive for now. Again, I can adjust later if I need to. There's nothing common, so I'm just going to pull out a positive 1. But then I get negative 3M plus 5J. If I look, they're similar, but they're actually opposite, not equal. So that means I got to go back, make that negative. That'll turn that positive. That'll turn that negative. And then I can see now my brackets match up. So again, I didn't need to rearrange it. The previous example we had to rearrange. If I would have assumed I had to rearrange it, I would have taken it out of a proper order and maybe made a new one that worked, but maybe I would have made something that didn't work, and then I would have been stuck on this question. Then if I'm stuck on the question, I might think, man, I don't understand this stuff. When you really do, you just overthought the question. Okay, let's finish it quickly here. So I'm going to pull out my GCF. 3M minus 5J. Write down the leftovers, 2C minus 1. Everything is good. Quick summary. First thing, break the 4 or 6 term polynomial into 2 equal groups. Remove the greatest common factor from each set of terms, the left half, the right half. Remove the common binomial or trinomial, depending on how many terms, if you had 6 terms, and collect the previous GCFs. All right, again, I hope this helped. If it didn't, find a teacher or come find me. Have a great night.